Now this question gives you a formula to work with, and it's telling you about some information, and it's saying that this information has been given correct to such an accuracy, so it's kind of crying out to you. Use error intervals, particularly by my car used, could Nathan be wrong? So it's asking you to think about what could have been the maximum petrol consumption, what could have been the least petrol consumption, to make a comparison with this statement. So the error interval for this is saying 3 significant figures. So there's our third significant figure. So it's in the ones column. So the error is always a half of the accuracy. So the error is plus or minus 0.5 for this one. And this one's saying it's the 3 significant figures as well, but this time the accuracy is 0.1, so the error is going to be plus or minus 0.05. What you've got to remember, guys, in measurements is that the error is always half times the accuracy given. So what we can do then is we can write out a error interval for the kilometres. So because it was given as 148 and the error is plus or minus a half from there, so it could be anything up to 148.5 less than, greater than 147.5, and for the petrol consumption in litres, then the litres could have been anything less than 11.85 and greater than or equal to 11.75. All we're doing, remember, is we're taking away the error from here to get the lower bound, and we're adding the error on to get the upper bound, and so forth. So because it's saying my car used less than 8 litres, that's telling me that I need to calculate the upper bound for consumption. If I find that the answer is less than 8, then that's fine. I can agree with what Nathan's saying, and so on. So upper bound for consumption is needed. So, to get the upper bound of consumption then, the formula says that so the petrol consumption is equal to, now the number of litres, if we want the maximum petrol consumption, then we want the maximum petrol, which is 11.85, and we need to divide by the number of kilometres. Well, we'll need the smallest number of kilometres, so 147.5, and the formula says you're going to times by 100, so, and then we put that in our calculator, so clear everything, so 11.85 times 100 equals, and then take the answer and then divide it by 147.5 equals. So we get an answer of 8.033. Now remember the units of this, it was litres per kilometre. So litres per kilometre. Because we're times by 100, so it's per 100 kilometres. Okay, so litres per 100 kilometres. Okay, so he said less than 8 litres. We've calculated 8.033. So basically we're going to conclude that Nathan is possibly wrong, as it can be greater than 8 litres per 100 kilometres. Okay, so that's how that question could have been answered, but it was recognising these key ideas. You know, when they're saying correct to, then they're really shouting out at you, use error intervals, and then work the rest of the question out.